right here, electronegativities tell you how badly you're going to fight for an electron.
I'd fight for it.
Fluorine has an electronegativity of 4.0, usually on the Pauling scale. I don't know what scale they're using. Some of them are different. That means it's going to fight harder than any atom. Can we play? It's going to fight harder than any atom to take an electron. Now, fluorine actually bonds to itself. So if two fluorine atoms come next to each other, one's pulling with an electronegativity of 4, the other one's pulling with an electronegativity of 4, guess what happens? They share the electrons. It is a tie, roughly. So if you have two atoms that have roughly the same electronegativities, usually the guidelines is like under 0.4. Okay? Then they're going to share them, and you're going to have what's called a covalent bond. Okay? They're both pulling on each other really hard. Those electrons get stuck in the middle, and they form a covalent bond, which we represent with a solid line. Okay? Now, the other possibility is when you get something like fluorine next to something like sodium. Okay? Sodium's got a really low electronegativity, like something like 0.9. It's in that area. So this guy's pretty tough, wants electrons really aggressively. This guy doesn't put up too much of a fight, so what happens is this electron gets ripped away.
Oh no!
Okay? And what you end up getting here is fluorine now has an extra negative. The electrons are negative, and it has a negative charge. Sodium over here just lost a negative, so its charge is positive. And then they attract each other. This has a negative charge, this has a positive charge, and this is called an ionic bond. This is an ionic bond.
I have a question.
Not yet.
All right.
What if they're pretty darn close, but not close enough? So let's say you have something like nitrogen. Nitrogen should be somewhere around 3. Fluorine's not strong enough to completely rip the electron away from oxygen. Kind of hangs out a little bit here. So they're going to share electrons because they both kind of want them. They're both really fighting, but they don't share them evenly. So what we end up with is we still end up with a covalent bond, but the sharing is not equal. Fluorine in this case, fluorine, this would be nitrogen. It's going to kind of hog the electrons, even though they're sharing. This happens all the time. If you have a brother or sister, your parents might buy you a toy you have to share.
No. Never had that. Never.
One of them might be using a heck of a lot more than the other. Yeah, we share it. Yeah.
I share a room with my sister.
There you go. So, anyways, this would be a polar covalent bond. It's called a polar covalent bond because what it does is it creates poles. What's a pole? Pole is an object that has a negative side and a positive side. The Earth is polar. Yeah?
Yeah.
Got the North Pole and the South Pole. People have bipolar personalities, two opposite personalities.
Get it?
So what happens is the fluorine kind of steals the electron a little bit. And there's a little symbol that means, it means partial. And if I mark this would work, this little symbol here means partial negative. It's kind of negative, a little bit negative. It's not full negative. If it was full negative, it would have ripped it away. And this side will have a partial positive. This is a polar covalent bond. So in the assignment, it's giving you compounds, yes? For example,
CH4.
CH4. So the question is, what kind of bonds are going to be formed here? Now, in the second part of this, you're going to have to write Lewis structures, Lewis diagrams, where you're going to write carbon bonded to 4 hydrogens. So what kind of bond is this going to be? Well, you look up the electronegativity of carbon. You'll see it should be somewhere around 2.5. And hydrogen should be somewhere around 2.1. I don't know what exact numbers they give.
It's about right.
Okay? And then based upon these two numbers,
Yeah, but do you subtract it like 4 times? For
no, just what's this bond here, and then
So just forget about
But
the
then when it's electronegativity change after you've taken away one electron? Once you've already made a bond, shouldn't that property change?
no, it does not, because it's the nucleus that is the part that's it's the nucleus which is the part which has that force. The nucleus isn't changing when it bonds. Yeah.
Are we writing down the type of bond along with the electronegativity?
You gotta write the electronegativities. You should write them down.
I did.
Simple math.
Yeah.
Then you would write ionic, polar, covalent.
Okay.
Order there.
Done.